Sorry.
Smoothing me.
And then you can put those 3 into your calculator and...
Should we get rid of the data points now? Or put them as 0?
Either or. Either, if you get rid of them, you'll have to get rid of like your 1 and 2 and your 6 and 7. Either way. It's just so you can get a sketch.
So these are called smoothing.
Yes. And then once you've had a look at it in your computer, in your calculator, on the next page you've got a graph, and you're going to draw all 3 graphs, just for some fun.
Draw them.
Yep. On the one, so make sure they're on the one plot. So with all your time down here, so 1, 2, 3, 4, 5, 6, 7. Whatever scale you want. You may have to plot a few points, or you may have to show how you've smoothed and where the smoothing points are, and in your SAC you may have to. So make sure you've got a key. Okay, let me just make sure the lingo I'm going to say is right.
Do you want to do the 3 mean and 5 mean?
Yes.
I have data in here, and I don't want to get rid of it.
Don't get rid of it then. Just keep it.
So what are you doing now?
Let me just make sure I'm saying it right. Yeah, cool.
So what are you doing now?
Yep, so put them in list 3. So the first one you don't have, so you can just put a 0.
Do you have to always put in 0?
If you don't, I'll just put it automatically anyway. So make sure you've also got a key. So you'll have to have your raw data in one colour. Your 3 mean smoothing in another colour. And then your 5 mean. Alright, and put them all on the wrong one graph. As you can see, mine's not to scale or to the actual data.
It still looks the same. Oh, right. Has to be roughly, has to do with this 3. Where's the other one? Is that right?
Are we going on the graph? Yep, so that's correct because you have to do the zeros. But if you were going to draw this stuff, so you've done it on sketch it, don't put in those first 2 lines because those 2 data points down there don't actually count.
They're both 0.
Yes. Make sense?
So you only, and with this, would you only put in that?
Is that your raw data?
Yeah.
No, so your raw data you put in everything because there is no 0. That was just a random one.
Oh, okay.
Yes.
Okay.
Yeah, just don't
So it's just stays that.
Yes.
So it's for like we don't.
Yes. Make sense? Yellow.
Should we be putting positions or just like there's no credit?
Yep. Put in a 0. Yep.
Yeah, I did 2 by 10.
I know. I did 3, but didn't fit.
Yeah, me too. We did raw, 3, and then 5. Raw is the one we break all the students. I don't know.
And then connect your points.
Huh?
Yeah, block type. And then you get that one. So when you go to draw it, just don't draw that first line because that's 0 and an actual data point. Yeah, that's just it. That's just your yeah, start there. Make sense? Cool. How are you guys? Okay? Yep.
Yeah.
And annoying as it is drawing these graphs, it's really good to practice them because in your exam, an exam question would be something like they've they've been given raw data, they've plotted the raw data graph, and then you might have to find one or two three mean smooth points, and then plot those points on the graph. Does that make sense? So knowing how to do that is quite important, because that's quite a common exam question.
Does it have to be a scale?
It should be, yeah.
What is scale?
So making sure all the, 1, 2, 3, 4, 5, 6, they're all the same distance apart,
Oh, right, yeah.
and you're going up by the same number.
Is that actually the same for both sides?
No. So you can go up by ones on one and tens on the other, that's fine.
Awesome.
Remember, you can use a break in your scale if you need to. So it means that if there's nothing in that bottom half, you've sort of just squashed it. Does that make sense? We all remember what I mean by a break?
The two lines.
The two lines. So on your
Does
graph.
that mean you can start at like 10?
Yeah, so if you wanted to start at 10, then go up by 5, instead of drawing that in, you can just draw 2 lines. And it just means that between 0 and 10, there's no data, and you've just squashed that part of the graph. All good?
Yes.
Awesome.
Can you put multiple on one graph?
Yes, so that's what you need to do. So say I've got 3
Yeah.
on the one, my graph will data something. So you've got your raw data, your 3 mean, and your 5 mean.
And then should we use the line as well?
Yes, definitely use the line. Yep.
It should be ruled or like what is curved?
Not ruled straight. Anyone having trouble with their graph? Wonderful.
Do it on bloody one. Yeah. Sometimes machine. Oh yes.
So with your graph, I think
Yeah.
it's that. You need to break in your
Yeah,
scale
yeah.
there and bring it down, and then make your scale bigger.
Yeah. As I wrote it down, I was like,
Yeah,
okay.
yeah, because otherwise if we put the break up
Yeah,
here,
yeah.
we're losing what we can actually
Yeah,
see.
cool.
Yeah. Yeah, so when you draw them, don't draw in these first 2 lines. So because these two aren't actual data points. So start it from here and start it from here, and then finish it here. Yeah. Make sense? Yeah. Yeah. So your 0 is, so our 0 is on this flat line here. You can go up by whatever you like. And what I was saying to Eric, do you understand what I mean by putting a break in the scale? Yeah, putting the 2 lines in. Yes. Yeah, so it's just saying that it's sort of, yeah, it is. So it's just showing them sort of like they just don't have the numbers on the 0 line. They're just sort of giving it a bit of space so you can see what's happening. But it's still correct what they've done, but it's just sort of not on the 0 line. It'd just be like if you drew another line down here and then put your numbers in. That's what it's showing. No, definitely keep your 0 on that bottom line. Yeah.
What's that break thing?
You can't put up to 10 because
So that break's just saying, so what's our lowest data point that we've got? 15. So if we didn't want to have, so we don't have any data up until 15. So instead of going 5, 10, 15, what we can do is we can put a break in our scale and start at 15 and then go up by 5s without going 5, 10. So what that means is that, yeah, we know there's more, you know, the graph actually should start down here, but there's nothing there to see, so we're just going to smush it up and squash it. If you aren't starting from 0, yes, you do.
And then you just write like.
Yep, so 2 observations that we should be able to see from this is that the 5 means smoothing. What did it do? What did 5 mean smoothing do? Yeah, good. So, what are they written? Yeah, more effective.
should we do it in 2 different colours?
Yes, definitely doing different colours because then you need to have a key saying what each colour is.
Oh, and you need the raw data.
Yes. Just so you can see what it's actually done. So we can see that the 5 mean smoothing is more effective than the 3 mean, and that's just because we've got a bigger set of data and we're finding the mean for a bigger set of data. So it's going to smooth it more.
Oh, when it's in observation 1, does that mean the raw data than the 3 means?
It's just saying, tell me 2 things that's happened since we've smoothed it. So one thing would be that the 5 mean smoothing is more effective in reducing the variation. And the other one would be from your graph, when we do a 5 mean smooth, it looks like there's no trend. It's just all staying the same. But if we look at the raw data, it could suggest that there's an increase. But once we do the 5 mean, we can see that there isn't.
How much time should you spend on this?
You wouldn't get a whole thing that you have to do in an exam. You may have to do one in a SAC, and absolute maximum 10 minutes. It doesn't have to look, it has to be neat and tidy and fairly accurate, but it doesn't have to be, oh my gosh, that little dot is 0.5 millimetre out. Yeah, so the title should be temperature.
Yeah. Okay, I'm glad it's not just me. Yeah.
Is that noise?
Yeah.
Yeah.
Miss Ryan, are they both meant to be back at 5 minutes?
It's just about what do we see in general.
Oh, okay, so
Yeah.
you can do it on whatever.
Yeah, you can do it on whatever.
On the bottom, should we write Monday, Tuesday, Wednesday?
Just writing 1, 2, 3, 4, 5, 6, 7 is fine. Because it's a chance there as well.
Should we write dates on the calendar?
Yeah, you can do that, yeah. How are we going with those graphs? We almost kind of nearly done. Yeah, cool. Maybe write those definitions down if you haven't already, and you can finish the graph later so that we can move on to the last bit. There we go. Yeah. This one, so which two of you drawn? You've drawn some, it's not working. Yep, then you've drawn some. So that's right. Alright, I'm just going to rub that bit off. Okay, the next thing we're going to do is 2-point smoothing mean. So when we're using an even number to smooth, we have to do it in 2 steps. Now on the other page, I've got a table, but the table probably isn't really that great to use because I haven't centered it correctly. So I'm just going to do it freehand over here, and it's probably going to make more sense to you if you just do it on the other side rather than try and put it in that table, because it's not going to fit perfectly. And I know some of you like to have everything really nice and neat. That's okay. So start off the same as we did usually. So still got the same data points going down one side. Just leave a bit more of a gap between them. Has everyone finished copying that down? Turn that off. Silence. Okay, and so we're going to do a 2-point mean smooth. So same as before, we're going to grab 2 points and find the mean between 2 points. And this is why the table wouldn't work, because it's actually, if we're finding the mean of 2 points, it's got to sit in between those 2 data points because it's the middle of those 2. Does that make sense?
Yeah.
So that's why the table would get a little bit confusing. And then we would divide that by 2. Yeah. I don't know what I'll do with my black one anyway. That's in my pocket. Oops. What did we get for our first one?
21.45.
Thank you. Second one?
25.6.
Third?
20.15.
Fourth?
13.3.
The next one?
13.45.
And the last one?
19.55.
Thank you. Okay, so as we can see, if these were, so that's our raw data, so at the moment that's our y, and then we've got our x, so we've got 1, 2, 3, 4, 5, 6, 7. If we had our, so we've got our data points, if we were to graph this and the results of this one, these actually don't line up to any x value. Does that make sense? What I'm saying? They're in between. So we actually can't graph these data points against our x list because they're not corresponding, they're not pairs. So to make pairs, we then need to do our mean smoothing again, which is what we call centering. So we've done our 2 mean smoothing, and then what we call is centering. So we're actually centering it back to our numbers. And again, we're going to lose our top and our bottom places as well. So we're not going to have any for the number 1 And we're not going to have any for the number 7 either. So we would be doing these two. Oops. So as we can see, this is really time consuming.
Why do we have to smooth again the second time?
Because these aren't actually, they're in the middle of two data points, so they actually don't have an X number that they correspond to. Oops, that goes down here. No, up. We've got 2, 3, 4, 5. Yeah. I can help, hopefully.
Thank you. It's just not letting me type in anything.
Oh, that is weird.
You can restart it.
Yeah.
Maybe.
Sorry, I don't know how to fix it. Sorry. So this one is number 2, number 3, number 4, number 5, number 6, and we don't have a number 7. So just 2, 3, 4, 5, and 6. Everyone follow what was just done? Yeah? Cool.
Why do you have to center it again?
Because if we look at these numbers, they're actually in between two X values. They actually don't have a corresponding X list value, so we can't actually plot them. If we were to do a 4-point mean smooth, we would do the same thing, but with 4 points. So we take the first 4, find their mean, take the next 4, find the mean, next 4, find their mean, and then we would have to centre them again using 4 points. So we always just use whatever number, we're doing 2, 4, 6, whatever, we just keep using that same number.
Is that because they're even?
Yes.
So if they're odd, you would
I
just
don't
do
see
that.
why can't you pick the bottom one?
The bottom one, because we don't have any data points left for it.
What bottom one?
24.9, number 7.
Do we graph it?
Yep, graph it, yep. So have a go, put it in your calculator, and then draw a graph on your sheet as well.
We have to put the raw data first, then the.
If you're graphing it on your calculator, the only reason you want to put your raw data in is so you can compare the two.
So we're just doing the endpoint?
Yes.
How come I
If you wanted to show two, so if you wanted to show all 3 graphs at once, when you go up to your, put it in as a scatter plot, turn on scatter plot 1, then go to the next, on next tab, which will say number 2, turn that scatter plot on, then go to the next tab which says 3, and then you'll get 3 scatter plots all up at once. Just like if you're doing a parallel plot. Yeah.
So how do you graph the center plot?
Yep, so you'd use your 1, 2, 3, 4, 5, 6, 7, and then the last numbers, so not those ones, these ones. Yep.
But that's the smooth. Oh, because that's just the box.
Yep.
So what are you graphing?
So if you were, so if we're graphing this one, you'd graph your X and then you're centered.
Is that what we're doing here?
Yeah.
Okay.
Yeah. And I was just saying, if you wanted to put all 3 on your calculator, just put 3 scatter plots. Turn 3 scatter plots on.
So do we skip number 1 and number 7?
Both.
Both.
Yep, because we don't have data points either side of them.
Okay, cool. Thank you.
That's okay. It's been such a long week of 3 days.
I'm gonna have you next week.
Actually,
It's alright, only 4 days.
Oh, very good.
There's a nice gradual ease into it.
Very
And
good.
then actually,
Yes.
then we have house plays. So get it
It's
down.
another 4 days.
And then the week after that, I'm pretty sure it's house.
Yes.
So,
Yes.
Like 20 something days.
4 days?
Yeah, 24 days.
and then I'm sure I did
Queen's birthday.
Oh,
Yeah.
yeah, that's a full week before.
Why am I doing
I
that?
want to get it opened up by next week. I
Yeah.
know.
It's so stupid.
Friggin' hell.
So nothing is next term.
That's not stressful for house captains or anything.
No, it's part of
So you don't use this one. You just use this one. With this one, they don't correspond to anything, so we can't write them. Like write this onto them. Does that make sense? What I just said, Colleen?
Do we do all questions?
So these ones go in these smooth points. So if you were to graph it, you put you put in your 1, 2, 3, 4, 5, 6, 7, and then you put these ones. Because these ones don't actually
I know.
correspond
You need to know that.
But we weren't even
Does that make sense? Yep,
having this one.
that's great.
Oh no.
What?
When
Yeah, so you won't be able to put your...
I'll actually cry if I'm on the bottom. If we have
Yeah, no temperature.
Girls, if you're all over that and you've finished, you can start 6B if you like.
Do you do all questions?
Yeah.
So meant to look like that.
Well, I know it is Friday afternoon and I know there's only 10 minutes left, so if you would discreetly like to chat, I may turn to blind eye.
Oh, wait. Sorry, we put the X ones are on the X line at the bottom.
Yep.
And then with the Y ones, we start with which do we use all 3 or just no?
Or just use the answers.
Just those ones?
Yep, because these ones don't correspond to anything because they're in between two numbers. So we can't graph these ones. That's why we do that next step.
Okay, so don't graph this.
Yeah, because we can't.
Oh yeah, I see.
So,
Do I still use like 18.1 on the graph as well?
you can if you want to graph them against each other. So as in like if you wanted to show the raw data and the smooth data, but if you just want to do the smooth data, your time and your answers.
Right or wrong?
How many decimals?
3. Unless to say otherwise, but usually say.